All right, Algebra 1, we're looking at linear inequalities and graphing them, okay? Our essential question is, how is graphing a linear inequality similar to graphing a linear equation? They're almost exactly the same. You plot the y-intercept, you move the slope, or you plot a point and you move the slope, and then you get that line, and that's where things get a little different. You're either going to get a solid or a dashed line, and then you're going to shade a region, okay? The difference with a linear is all the answers are on the line. With an inequality, they're on one side of the line or the other, so you can get an infinite number of points that way, okay? And I'll show you what I mean there. We're going to start out talking about what is a solution of an inequality. And a solution is when you can take that ordered pair and it's in the shaded region, or in our case, what you'll see on the homeworks is you plug it into the equation for x and y, and if you get a true statement, it's a solution. Okay, similar to what we did when we started the linear equations. So if we're taking the point 2 or 1, 2, and we want to know if it's a solution of y is greater than x minus 3, I'm going to plug my 2 into the y, my 1 into the x. Is 2 greater than negative 2? Yes. So it's a solution. Okay, and I'll show you what that looks like. How do you graph it? Okay, graph the equation like the linears. Plot the y-intercept, move the slope, find your 2 points. Or plot a point and move the slope so you have your 2 points. Now, you either get a solid or a dashed. Sorry about that. A solid or a dashed line when you graph it. When you graph this thing, if your inequality is something like that where it's greater than or less than, okay, then you're going to get a dashed. So right here, this would be a greater than or equal to, less than or equal to. If it has an equal to it, it's a solid line. If it's just greater than or less than, then it's a dashed. Okay? You'll see an example of each of those. And then if it's greater than or greater than or equal to, y is bigger, y is being eaten up, then you're going to graph up from your line. You shade down if y is less than or equal to. Okay? And that side that you shade, that's where your solutions are in. Your solutions are in the shaded side. Let's take a look at that. It's easier to see when you graph it. Probably looks like a little bit of a hodgepodge first. When you see the graph y is greater than x minus 3 than what we just did, we look and see that our y-intercept is negative 3. Our slope is right here. It's 1 over 1. Okay? So I plot the negative 3. I move up 1 and over to the right, just like we've been doing. Now, because my inequality does not have an equal, I dash the line. That means I can't take a solution off the line. Okay? Because if I took an ordered pair off the line, they would be equal. Okay? Y wouldn't be bigger. So that's why we dash it. It means you can't take a point off it. And since y is greater than, where are the bigger y's at? Up here. So we shade up. So we got this whole region right here. Any point on this side can be plugged into here, like 0, 0. Is 0 greater than negative 3? Yes. Okay. Any point down here would not work. You could take one of these points, plug it in, and you'll get a false statement. You get something like 5 is greater than 10, and it's not. Okay? So there's an inequality, a greater than, no equal, so we got a dash. How about this one? Graph y is less than or equal to negative 1/2 x plus 1. Y-intercept is 1, slope is negative 1/2, so I plot my 1, I move down 1 to the right 3, there's my second point. I notice I have an equal in my inequality, so I'm going to draw a solid line. Y is less than, so I shade down. So all my solutions are down here, like again, 0, 0. Is 0 less than 1? Sure is. Okay, 0, 0 is a nice one to always check with. Okay, so you see no equals, equals, dashed, solid. Y is greater than, shade up. Y is less than, shade down. Remember, we eat up the bigger number, so that's how you can tell if y is bigger or less. The last two examples I want to look at here are special graphs. When you get an x greater than or equal to, less than, whatever, a number. Notice there's no y. Okay? That's a special case. X is equal to negative 1 right here, all along this line. Now, why did I dash it? Because there is no equal here. Okay? So I get a dashed line through negative 1 for the x. Every x is going to give us a vertical line. Every time. And since x is bigger, it's being eaten up, x is greater, the bigger x's are out here, so I shade to the right. If it was less than, I'd shade to the left. Okay? Here, this kind of falls in line with what we're doing. There's no x because the slope is 0. But if you think about if x is a vertical line, then y with no x is going to be horizontal. And it's horizontal because the slope is 0. Okay? Here, there's no slope. Here, m is equal to 0. The slope is 0. If you're 0 slope, you're flat. Okay, horizontal. And that's why there's no x, because mx plus b, 0 times x is 0. So you're just left with your b term, your y-intercept. So slope is 0, it's flat. I've got an equal to it, that's why I drew a solid line. Y is greater than, it's being eaten up. Where the bigger y is at? Up here, so I shade up. Okay? Two special cases. So graph like we have been, check the signs to see if it's going to be a dashed or a solid line. If y is greater, you shade up. If y is less, then you shade down. Pretty straightforward. Okay? We're going to look at more examples of this tomorrow. We'll see you then. Bye.